So looking at the cardiac cycle in detail, that's what we're going to do in this one. Like I said, I'm going to try to put together pieces of the puzzle so you guys can kind of see the whole thing. So again, just to define diastole and systole. Diastole is the relaxation of the heart when it's filling, and systole is the contraction of the heart. I don't love this diagram because it kind of starts to show that the atria are going to contract at the end of diastole, but really diastole is truly the relaxed version of the heart when it's filling. What I do like about these diagrams and why I included them is it shows that the AV valves are open during diastole. And the reason why is you got to think about right now you have blood coming in from the superior and inferior vena cava filling your right atrium. That's going to want to dump into your right ventricle through that tricuspid valve, that AV valve. So you have blood coming from here, blood coming from here. It's filling up, and coming down into your right ventricle. At the same time, you have blood coming back from your lungs through your pulmonary veins, and they're going into the left atrium through that mitral valve into your left ventricle. So this is the filling stage for your heart. And this is almost as important as the contraction stage, because this is the volume of blood that your heart has to work with, right? That it's going to send either into your lungs or into your bodies. So if you're looking at the right side of the heart, it's going to be sending that volume of blood to your lungs to get oxygen. And if you're looking at the left side of your heart, it's going to send that blood out to your body to oxygenate your tissues and your organs, okay? So diastole is the relaxed version of your heart where it's filling with blood. Your AV valves are open because that blood is going from both your right and left atrium into those ventricles, getting ready for your heartbeat, getting ready for that contraction. So this is the filling stage. When you have systole occurring, and we talked about that conduction system, you have that SA node that's going to fire here to your AV node, to that bundle of His, that's going to go down your left and right bundle branches to your Purkinje fibers, and you're going to see this contraction happen. When the contraction happens, at this point, your AV valves are going to be closed and your semilunar valves are going to be open. Now, your semilunar valves are just the valves that close off your arteries. So here you have your pulmonary semilunar valve, or your pulmonary valve, aortic valve, and that's going to open because it's going to want all of that blood that just filled up the right side of your heart to get pushed into your lungs so it can get oxygen. And on the left side, you see this AV valve is now closed and this semilunar valve is now open. This is your aortic semilunar valve, your aortic valve. And this is going to want to open because, again, when this heart contracts down during systole, it's going to want to push that blood out to your body. So that's the way the conduction kind of works with the circulation. You're filling over here in this relaxed stage. You've got these gates that are open, allowing that blood flow to happen. Over here, you're contracting. These gates are now closed because you never want blood to go backwards. You always want them to move forward. So these gates are closed and these ones are now open, allowing that blood to be ejected into your lungs and ejected out to your body. So that is how we're going to kind of start to connect the circulation with the conduction and the contraction, and it's all going to come together. So there are heart sounds that are actually associated with valves. We don't do as much with heart tones as respiratory therapists as other specialties will do. But one thing that you do need to realize is that there's a lub and a dub. So a lub is the first heart sound. It's also called S1, as in sound 1. And you have the dub, which is the second heart sound, or S2 or sound 2. And so the noise of the lub is when the AV valves shut. Okay, and going back to this previous ones, the AV valves shut right at the beginning of systole. All right, so here they are open during this filling stage with blood coming in and filling, and it's allowing blood to move freely from the right and left atrium into their corresponding ventricles. When the heart is getting ready to contract, these need to shut, because if this contracts down and these are open, that blood is going to go backwards, right? So when at the beginning of systole, at the beginning of a heartbeat, when the ventricles are about to contract down, these AV valves slam shut. That makes that first heart sound the lub, all right? When you hear the second heart sound, it's going to be during the repolarization or the relaxation period. So coming back over here, after the heart is contracted and ejected the blood out and it's now relaxing, okay, and it's about to fill again, these valves slam shut. Your semilunar valves slam shut. And again, this is for the same reason. When you have all this blood filling, you don't want it kind of leaking through here. You want to wait until you can force it with the contractions so you get the most blood flow possible, so you get the greatest cardiac output. So your dub is the sound of these valves closing. Your semilunar valves will always be closed when your AV valves are open. Your AV valves will always be closed when your semilunar valves are open. They are not open at the same time, and you can kind of understand why as you get more familiar with the circulation and the process of things. So those are your two heart sounds, and I have them here. When AV valves are shut, the semilunar valves are open, systole. When semilunar valves are shut, AV valves are open, diastole. And I just have this defined on this slide. So the order of electroconductivity, which we talked about on the previous lecture, but we're just going to go through it again. So you have your SA node, which is your atrial depolarization. Depolarization means contraction, right? It's what initiates that heart rate. It's the pacemaker of the heart. It's going to fire a signal to the AV node. This is going to send a signal to the AV bundle or the bundle of His when the ventricles are filled, right? This AV bundle is going to send it to the bundle of His, and that's going to close the AV valves. That's going to be your first heart sound, that lub. The closing of the AV valves is the lub. You're going to have the left and right bundle branches carrying the signal down through your ventricles, and then that's your QRS complex coming up through the Purkinje fibers to complete that depolarization, to complete that contraction. I feel like this slide is kind of useless in an online format right now because I don't have a visual to go with it, so I'm just going to keep going. We went through this entire process with a diagram, so watch that one. It's in the lecture before this. I will go through it again with a diagram, but this is just the same thing written out in words. I feel like when you're saying it out loud and you don't have a diagram associated with it, it's super confusing, so I'm just going to keep going. This electroconductivity responds or correlates to an EKG or an ECG. So the P wave is your atrial depolarization. Your QRS complex is your ventricle depolarization or contraction. And your T wave is your ventricular repolarization or relaxation. So we went over that. So this is just a slide that shows you the order of blood flow. Again, I always start at the superior inferior vena cava, but really you can start anywhere in here. It's a circle, it's a loop. So this is where I always start, right? But essentially you could start anywhere in here and it doesn't really matter. It's all a loop. But it's just another place that I'm highlighting the order of blood flow because it's very, very, very important that you guys can follow the circulation from really any point. This is where I write out the cardiac cycle, the systole and diastole of a heartbeat, and I write the conduction as you follow it through, and I explain what happens at each point. I don't think I'm going to read this out loud because I think you guys can all read, and I don't want to waste your time. So this is kind of where I include it all together. So not just the electroconductivity, but also what it is on the EKG, and then also what's happening with like the blood filling and the ejection of blood. So this is kind of a good place to see it all in one spot. There's a YouTube video here that you can look at to see kind of the same order. And then these are your lecture questions. I know that was quick, but I don't want to waste your time reading something too that I know you guys can read. And hopefully I'll come up with like supplementary things to help explain this process a little bit more.